Hello everyone, welcome to my YouTube channel. So here today we are looking at the wave duality of light. So what is it? So this is simply an explanation that explains how light behaves as a wave and also as a particle. So let's begin with how light behaves as a wave. So we know to say if you have light is a wave because it has got crests and troughs. So this is a trough, this is a crest. So now it has various features such as the wavelength, which is the distance between two successive troughs. These are troughs, or the distance between two successive crests. So that is light, it is a wave. So we can verify that light is a wave because it is able to more like be able to diffract. So it is able to diffract. So diffraction is the phenomenon which happens when light passes through a slit. So a slit is more like a small hole between let's say two items like that. So like for example, if we have something like this, so when light comes, so let's say we have a light source like that. So when light comes, it will be able to produce these rays. So as it passes, it is able to diffract, or rather to diffract like that. So this is the phenomenon which we call diffraction. Now this leads to the formation of very bright patches at one point, and other points it might appear to be dark like that. So due to this pattern, we can be able to see that. So this is light's ability to be able to diffract. And also there is interference. So interference, we are simply referring to how light is able to combine to form very brightly colored at some points like that. So interference is when, let's say, we have a wave of light like that, we have another wave of light like that. So these two waves, as they combine to form a bigger wave. So that is the constructive interference, or light has got the ability of more like canceling itself like this. If we have light passing like that, it will cancel itself and you won't be able to see any light. So that is destructive or constructive interference, but that is mainly what we call interference. This is the same reason why we are able to see some points are brightly colored, whilst other points such as this space are not brightly colored. This is the interference aspect of light. So now light is able to behave as a wave, which we have discussed. Now light is also able to behave as a particle. So what is the behavior of light as a particle? So the behavior of light as a particle can be described as by the famous experiment which we call the photoelectric effect. So what is this photoelectric effect? So the photoelectric effect is the phenomenon which happens in which light is able to knock off electrons on a hot surface. So let's discuss about it. So light is made up of small particles which we call photons. So when photons hit a surface of a metal, they are able to eject electrons. So that is the behavior of a particle. It is able to displace other particles in order to eject electrons like that. So that is what we call the photoelectric effect. Now how does it work? So the photoelectric effect operates on the aspect of frequency. So it is only after a certain frequency is achieved, that is when the particle will be able to that is when the light will be able to more like eject an electron. So an electron will be moved from a metal surface only if a certain frequency is reached. You can just think of it as if you're going, let's say, to a certain place. For you to pass a toll gate, you need to have certain amount of money. Let's say if your car costs 200 kwacha, it is only after you pay this 200 kwacha that's when you'll be allowed to pass. So it is the same aspect with the photoelectric effect. Under this one, we have what we call the threshold. So we have the threshold frequency. So the threshold frequency is the minimum amount of frequency that is required. So the threshold frequency is the minimum frequency required to eject an electron. So it is only after this amount that a particle can be able to be displaced. So this is studied due to the aspect that if you have light that is very, very bright, if you have very, very bright light, but it has got low frequency below the threshold frequency, it will not be able to eject electrons, or rather it won't be able to remove electrons. So electrons are only removed if a frequency of, let's say, the threshold frequency, let's say for example if it is 20 Hz, so 20 Hz can be able to eject an electron even if it is dim. But if we have let's say this is the minimum, then we have something like 10 Hz, that is the amount of light, then you will find that an electron won't be ejected no matter the brightness. Even if you have a lot of light, it doesn't matter. Or what matters is the frequency. If the frequency is reached, the threshold frequency, that is when an electron will be able to be ejected. So that is how the photoelectric effect works. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.